All right, let's take a look at 1241, Part A, where you have the reaction of 2-butanone with 6 moles of the cerium-4 ion plus 3 moles of water to yield acetic acid plus 6 moles of cerium-3 and 6 moles of the hydrogen ion. Part A asks, given acetic acid appears at an average rate of 4.6 times 10 to the negative 8 molar per second, what is the rate of reaction in terms of the hydrogen ion during that same interval? So, if we go back to our equation, we see that it's a 2, I need to change color here, it's a 2 to 6 ratio between our acetic acid and our hydrogen. For every 2 things of acetic acid we form 6 for hydrogen. So 4.6 times 10 to the negative 8th molar of our acetic acid times 2 molar plus 2 times 2 moles of acetic acid, where they'll cancel out, times 3 moles of, 6 moles of the hydrogen ion. I'm doing the math in my head already here. 6 moles of the hydrogen ion, multiply everything on top, divide through by everything on the bottom, and you wind up with 1.4 times 10 to the negative 2nd molar per second. So that's Part A. In Part B, you're doing something similar, but in Part B, I need to keep the reaction here. I'm scooting this around on the screen so that I can get to the Part B here. Oh, come on. My stylus is not wanting to cooperate. Part B wants to know, whoops. Part B wants to know the rate of change of the cerium-4 ion during that same interval. So once again, it's just that simple math of looking at your chemical equation and discovering that if you look at your chemical equation, you've got 6 cerium-4 ions and to every 2 of my acetic acid. So if I have a 4.6 times 10 to the negative 8th molar per second times, divide by 2 acetic acid to cancel it out, times 6 to get where I'm going, and surprise, surprise, I wind up with the same answer when I do the same math. And I wind up with 1.4 times 10 to the negative 7th molars per second. Chemistry's easy, life is hard.